Hello, this is test session. I am checking whether I can be able to record or not. This is Docker image installation process. Okay, Docker install process, sudo Amazon Linux. By default, Docker works with root user and other user can only access to Docker with sudo commands. However, can bypass. Okay, so let's see this stop the recording. RAM, CPU, and OS, right? So these things run Docker image. Okay, that time you will get. Hello friends, so welcome to my YouTube channel. Today we will be see the Docker day 2. Okay, so what Docker does is Docker provides our containerization platform, right? Containerization platform. Okay, so Docker, let's say I have one. Uh, so yesterday we learned about this is AWS provider, right? Okay, AWS provider. This is, let's say, this is AWS infrastructure. Okay, AWS provider. Then there will be EC2, right? Amazon EC2. Let's say virtual server in the Amazon cloud, EC2. Okay, and one more we have the smallest entity is called container. Okay, so these three things. Okay, so these three things I want to arrange them in one architecture. Okay, so how can I will we do that, right? So let's say here is my AWS provider. Then copy paste. In that I will be having EC2 instance. Okay, and in that I will be having the container with the help of Docker. Okay, so now let's take before Docker example, right? So now we are considering the before Docker scenario. So what we will be having, what are the requirements? Let's say if we are having some uh, one application is to be developed, right? So let's say Python application you have to develop. So what will be your requirement? Let's say without Docker, okay. So you will be requiring first requirement will be we have to create instance, right? Create instance EC2. Okay, so this EC2 will install Python, right? So to develop Python application, you should be having Python software installed on that EC2 instance, right? Okay, then third step will be the copy the code. Okay, copy the code where you want to deploy your application on that server, right? So along with the dependencies, and then fourth will be run and execute the code, right? Run the Python code. Okay, so these are the four steps. Okay, these are the four steps which will be required if I want to develop my application, the Python application onto the EC2 instance, right? So if I add all the application in one server, right? If I add all, let's say I have another application, let's say Java application, right? The same is if I have some Java application, okay. So in that case, if you there will be same steps, right? We have to create EC2 instance, install Java, copy the code, and then run the Java code. Okay. So if you uh, deploy the Python application and the Java application onto one server, okay. So that will be monolithic, right? So monolithic means mono means one, right? So in one server you are deploying many application. That is called it is monolithic. So if that server goes down, both the application will be down. Okay. So to overcome this inside EC2, each app, each server, we have to host multiple app into one EC2 server, right? So this is the containerization platform, right? So if I let, let's say this is if you see the Flipkart, right? In Flipkart, what we can see there is a um, that it is a microservices approach, right? So here we have mobiles and tablets, and electronic section is different, and let's say fashion system is different, grocery system is there, right? So these many icons, okay, that is lead to different applications, okay. So these are not hosted in one server, okay. These are hosted into different let's say containerization platform, maybe in the one server, but that will be having the redundancy, okay. So let's let's say here we have grocery, right? And then here we have travel, right? And then so if I want to develop an application, so I will be requiring two separate servers, okay. So this grocery will be deployed to this server, and this travel will be deployed to this server. So if you see, if my application grows, if my web application grows along with the time, then I will be requiring different EC2 servers. That is not feasible, right? Means you will be also requiring some, uh, let's say, cost saving, right? If you have a client requirement, let's say, let's take into consideration that you have a client requirement. Okay, what is the client requirement? Sorry for the spelling mistakes. Client requirement. Okay, so first is I need high availability, right? So high availability, how I will be achieving this? By deploying the multiple servers for the same application. So if I take into consideration this grocery application, I will be installing one server and then parallel to other this server. Okay, so two servers, let's say at least two servers you will be having grocery, and then for same thing will be for the travel. There also we will be requiring two different servers. Okay, so in e-commerce website there is a microservices approach. Okay, that's split into different multiple apps host into different server. So you can see that this architecture, okay, this architecture, one more, one more, okay. So here, let's say if you have 100 applications like this, so you will have to, you will be needing 100 and to 200 200 servers over there, and for that you will be also requiring the auto scaling, load balancer. So that much of the quantity goes, and the client requirement is also with the client requirement is second is the customer is having the less budget, right? So this thing we also need to take into consideration, right? So, so to suffice this requirement for the less budget, we can deploy this, we can employ the microservices approach. Okay, microservices approach to deploy this application. Okay, so these application. So what I will draw the architecture in another paint. Okay, so that it won't be confusing. Okay, where it is paint. Yeah. Okay. So let's say this is my AWS infrastructure. Okay. So this is my AWS provider. First layer will be, as we see, as we have seen yesterday, first layer is the hardware, right? Okay, can change the color. Hardware, right? Then second layer will be the OS, right? Operating system. And on top of this operating system, you will be requiring Docker, right? So on top of this OS, you will requiring Docker. Okay. So let's say I have a, then we will be having this grocery application, right? So I am considering high availability requirement. I am taking this two applications, two grocery applications. Okay, and let's say different color for this travel. Okay, so this is travel travel application. So I'm taking two containers over. Okay, so this is my container, right? So what is happening in container also I will be having one hardware, right? So for this container also I will be requiring the OS, right? Okay, OS. And then here is the your grocery application, right? Same is like here. First layer will be hardware, and next layer will be OS. This OS is of your choice. Okay, you can deploy any OS into this. Okay, this OS has nothing to do with this host machine OS. Okay, travel app, right? Okay, so group of, let's say group of users, okay, group of users that will be accessing. I'm just taking the picture. Let's say snippet. Okay, okay. snippet. Okay, so these are the group of users, right? Okay, okay, so these are the group of users who will be accessing, right? So I will also be needing, so these group of users can access these applications by, okay, and here, so these uh, this scaling, okay, so this is the scaling grocery app, right? We are creating multiple applications in travel also and grocery, okay. So this scaling we can get by the, there is a concept in the Kubernetes, right? So Kubernetes is Kubernetes is Kubernetes Kubernetes is the orchestration tool, right? Kubernetes, right? Auto scaling, okay, or let's say load balancer, okay. So if you are running multiple application, multiple containers, okay, so uh, for that you will also be requiring load balancer, okay. This load balancer will be generated by the Kubernetes only, right? I'm not getting, okay, let's see, okay, so you'll be taking here, okay, okay. So I will be accessing through the load balancer, and load balancer will distribute the load on the multiple containers, okay. So here Docker will create the containers only, but this the orchestration of this app will be done by the Kubernetes, right? Clear this concept, okay. So if you want to develop this Python application into Docker, first you need what? EC2 instance, right? So my EC2 instance is ready, right? EC2 is ready. Then I need to install Docker on top of the OS. Now the actual process will start. Okay, so now server is required. This EC2 server is not for this EC2. Okay, this is the EC2. This is not for application deployment. This EC2 is to host the Docker, right? So this is Docker. To host this Docker, I need this EC2, right? Means everything will be deployed on Docker. So to run this Python code on top of the Docker, okay, to run this Python code on top of the Docker, what is our requirement? I need the OS, right? I need on top of OS, I need Docker. This OS will pro and this OS, okay, this container OS will be provided by the Docker. There is a Docker Hub registry, right? From which Docker will pull the required application, required OS. Okay, so let's say for this there is a means, so we have uh, written down these steps, right? We have to create EC2 instance, right? EC2 instance is created. Okay, so install Python, copy the code, run the Python code. So these are the four steps that we need to define somewhere in the Docker, right? So where we will define those steps, that is in the Docker file concept. Okay, so let's see now the Docker file concept. Okay, so Docker file is okay. Just take the browse. Okay, so first is you will be requiring the first step is what OS required, right? OS required. Okay, so I will be having this, let's say Ubuntu OS, right? This is my requirement. This is the client requirement. Okay, Ubuntu. So and this Ubuntu, this will be taken by the Docker from the Docker repository. Okay, so this is the base image. Let's say base image. It will not have the dependencies, right? So you will decide that which dependency you need to add into this base image. Okay, this is completely base image. It will be having nothing any dependencies. Okay, then what is the second step? Install Python, right? So you have selected the Ubuntu as a base image, right? Okay, then let's say here is our second step, that is install Python. Install Python means what? You have to install a Python package libraries software onto the EC2. Okay, and then third step will be what? Copy the code. Okay, copy the code. Copy the code. Copy the code where? Copy the code into the server where I will execute this code, right? And then fourth will be run the code, or execute the code, right? Okay, so this is what, these are the instructions, right? These are the instruction you are writing in one file, and that file is called Docker file. Okay, so this is the Ubuntu base image. You can install the Python onto this base image, install Python and its dependencies into this base image. So you can customize your requirement onto this particular base image so that your code won't be getting heavy. That is the reason why it is the lightweight. So yesterday we see in, right, the Docker Hub. Okay, Docker Hub concept. Okay, in the Docker Hub, where is the Docker Hub? So this is very lightweight. Okay, I can show you, no problem. Docker Hub. This is just only yesterday we have seen, right? This is just only at 28, sorry, 28 MB only, this file, right? So you imagine, the if you take the Ubuntu ISO image from the internet, no, it is of 6 GB, and this base image from the Docker Hub, okay, it is only it is only 28 MB. So see, you just see the comparison, where is 6 GB and where is 28 MB. So that is the difference, right? That is the difference. That is why it is lightweight. Okay, so uh, where is in tags, right? Ubuntu. So you can see this is 28 MB. This is the pure base image, right? And so if you, what is your dependency? Dependency will be of 1 MB, right? Copy the code will be nothing. So ultimately you will maybe having some 30 MB of application in this Docker file, right? So your application will be of only 30 MB. So it will be execute earlier as compared to the heavyweight the applications, right? So that is the reason. So once you have the Docker file ready, right? When you when you build the Docker file, what you get is what you get is container. Okay, so this container, right? So this is the process flow. Okay, so Docker image is the custom image, right? This is the custom image, means you have designed as per your requirement only, no extra dependencies. Okay, that is why the containers are lightweight, right? This is the reason the containers are lightweight, because you are defining only the required dependencies. If you are developing your Python application, you are just taking the Python code and Python dependencies. That's it. You don't need to have Tomcat or some HTTPD applications or dependencies into that unnecessarily, right? So this is the difference. So we can see now the, let's say, sorry, we can see now the mm, Docker installation, right? So let's launch one instance. Test. So we are creating, this is the AWS virtual cloud, right? We are just taking the EC2 instance. We are generating one EC2 instance. T2 macro. Okay. Okay. Nano key pair test. Okay. Launch wizard to give the security group. And here is the ATM 8 GB, and just check launch. Okay, so you have installed the EC2 instance. Just try to connect into that. Sorry, my internet is working very slow. That is the reason. Just give me a moment. Okay, just connect. Okay, just connect.
Okay, so just this is the installation process. Okay, Docker install. Okay, just copy this. We are using sudo, right? Because we are logged in into the uh, EC2 instance with the EC2 user. That is why, right? Paste. Okay, so this is we are installing the Docker in the EC2 instance. It is taking time due to my network connection is weak. Sorry for that. Okay, so Docker installation is complete. So we just need to start the Docker, right? By this command systemctl start. This will start the Docker process, and we can check whether it is started or not by this command, the status, right? Yeah, it is active and running. Okay, so you can check whether it's a Docker version, right? Okay, sorry, Docker version. Okay, so okay, we are getting permission denied, right? Permission denied because the are trying to connect to the Docker socket, right? Okay, so we need to enable the Docker socket also, right? So this is the command to give access the Docker daemon to run Docker server. Okay, yeah, now we can see the client and server. This is the client, Docker client, and this is the Docker server, right? So this is the installation process of the Docker version. So this Docker version you can check by this command also. This is 25.08. Okay, so one more topic is left, that is the Docker architecture, right? Docker architecture, Docker architecture. Okay, images. Okay, so see, this is the Docker architecture. Okay, I'm expanding it. So this is the Docker architecture. This is the client, right? Client means from where you are executing the command, right? This is, let's say, Docker. Now this is the client. We are executing the Docker command from this Docker pull now Ubuntu. Okay, so it will pull the Docker. It will pull the Ubuntu image from the Docker repository, right? So see here. So we have just executed the command Docker pull on the onto the client onto the EC2 instance where the Docker is installed. So this Docker pull will be go to the Docker host. Okay, so it will be connecting with the Docker daemon, and from the Docker daemon it will check in the local repository whether this Docker whether this Ubuntu image is present here or not. Okay, in the local repository. Okay, so if it is not present here, then it will fetch from the Docker remote repository. This is the remote repository from it will fetch. So once it will fetch from this remote repository, it will store in the local repository here. Okay, and then it will give back the response to the client. So this is the client, this is Docker host, and this is the registry. Okay, so here we have just executed the Docker pull Ubuntu, right? So these are the Docker commands, right? Docker build. Docker build is to create. We have already seen it, means in the concept. So when you build the Docker file, you will get the Docker image, and when you run the Docker image, you will get the container, right? So Docker run, Docker build, and Docker pull. So this is the service flow of the Docker architecture, right? How this client communicates with the Docker host and registry. So uh, when you build the Docker image, then it will be stored in the here, right, in the local repository. And when you run the Docker run, okay, Docker run, whatever the build image you have present created after the Docker build, then those containers will be stored here. Okay, so this was the our second day topic for the Docker. Hope you like it. I will be coming more on the Docker in the upcoming sessions. Thank you. Thank you for seeing. Bye bye.